short video on properties of exponents. We're going to talk about properties of exponents for multiplication and division, as well as what to do with negative exponents. All right, so the first thing that we have are product of powers. And all that means is when I have a number raised to a power multiplied by that same number raised to another power. So I have 5 to the third times 5 to the fourth. Well, what the product of powers says is that if the base is the same, you can keep the base, that's the 5, and just add the exponents. So that's going to equal 5 to the 7th power. Okay? When I talk about quotient of powers, same thing. What about 7 to the 8th divided by 7 to the 3rd? So I'm going to keep the base the same. And instead of, when we use quotient or division, we're going to subtract the powers. 8 minus 3, that equals 7 to the 5th. Okay? And then the last one that we're going to talk about is a power raised to a power. So, for example, if I have 6 to the 4th power raised to the 3rd power. That is essentially the same thing as 6 to the 4th times 3, which equals 6 to the 12th power, okay? So those are basically the three main properties of exponents or powers that we use in geometry. Negative exponents. I went through your acuity and I saw that a lot of you struggle with the negative exponent piece. So the rule is to write the number as a reciprocal with a positive exponent. So let's do a couple of examples. Let's say 7 to the negative 2. Well, I need to write the number as a reciprocal. So the reciprocal of 7 is 1 over 7, and then I'm going to turn my power, instead of being a negative power or a negative exponent, to a positive exponent. Okay? Which is the same thing as 1 over 49. I teach my pre-algebra students this. I call it DRIP, which stands for drop it positive. I don't know if that'll help you remember or not, but we DRIP all negative exponents. So let's do another example. What about 8 to the negative 4? That's the same thing as 1 over 8 to the positive 4, which is the same thing as 1 over 8 to the 4th power is 4,096. Okay? So let's do some example problems. All right. So I think I have like 3 example problems on this slide. So 5 to the negative 3rd. Remember, I'm going to drop it positive. So drop means reciprocate. It positive, this comes down here and becomes positive. Drop it positive. That's the same thing as 1 over 125. Okay? If I have 6 to the negative 4th power, that's the same thing as 1 over 6 to the 4th power. And 6 to the 4th power. So 1,296. Okay? This one is a little bit different. This uses powers of products and quotients of products. So what I'm going to do here is, this is the same thing. I'm going to rewrite this 2 ways. First of all, I'm going to rewrite this as, this is the same thing as 2 to the negative 5th over 3 to the negative 5th. Okay? So now I want to get rid of those negative powers. So remember, in order to get rid of the negative powers, the first thing that I want to do is reciprocate this. I'm going to reciprocate my fraction, and then both of those powers are now positive. 3 to the 5th power is 243, and 2 to the 5th power is 32. Okay? So that's what 2 do one more on here, okay? So I have one more example. So remember, this is the same thing as 3 to the negative fourth over 2 to the negative fourth. To get rid of those negative powers, I want to drop it positive, so reciprocate. 2 over 3, and now my exponents are positive. 2 to the fourth, 16. 3 to the fourth, 81 here. Okay? Lastly is when you're asked to evaluate. Sometimes you're asked to evaluate 2 times 2 to the negative 3 times 5 to the fourth. Alright? The next thing that I'm going to do is get rid of those negative exponents. So I know that this is going to be a fraction. It's going to end up looking like a fraction. On the bottom, I'm going to have 5 to the second power. I'm also going to put 2 to the third power on the bottom. Okay? Essentially, they're both over 1, but 1 times anything, 1 times 5, is just that. So on the top, I have 5 to the fourth. So really, I don't need to put those 1s over the top. So now I'm going to evaluate this, but I'm going to remember that if the base is the same, I can keep the base and subtract the exponents. So this is the same thing as 5 to the fourth minus 2 over 2 to the third. Well, 5 to the fourth minus 2 is 5 squared over 2 to the third, which equals 25 over 8. Not bad, right? Okay, let's try that one more time. So now let's do this one. I have 3 to the negative fourth times 2 to the negative fourth times 2 to the seventh times 3 to the third. Okay? So I want to get rid of those negative exponents, and I know in order to do that I'm going to have to create some fractions. So that 3 to the negative 4 is going to be in the denominator now. 3 to the fourth power times 2 to the fourth power. And then I have a 2 to the seventh power up top. And times a 3 to the third power. Okay? Alright, so let's look at this. Let's see. Well, 7 minus 4 is 3. So I'm left with 2 to the third on top in the numerator. What about the denominator? If I take 3 minus 4, I'm going to end up with a negative, so I can cancel out the 3 and turn this into a 1, which is essentially 3 to the first power, or 3. So this problem comes out to be 8 over 3 when I evaluate that. Okay? Much easier than if you had actually multiplied out these problems. Okay? Good luck. So we've talked about properties of exponents and what to do with negative exponents. You have a 6-question worksheet that just asks you to evaluate. You're going to evaluate some powers. And then once you're finished with that, you have your acuity diagnostic. Good luck.